Tuple to nested object. Welcome, Theo. So this one is a pretty cool one. It's just a tuple as an input. And in this case, we just have some little strings. And what's outputted is a nested object. So we've done a prior challenge. Theo, you and I didn't do it, but I think there was a prior challenge that had you create like a flat object just from these tuples. But this one, it kind of gives you like a path, like it's like a Lodash path or a Lambda path, and then the value at the end of the line. So yeah, I mean, what do you think about this? How would you even like approach something like this?
I would first have to think a lot more. This is very far from my norm.
The first thing is like, I'll show you a setup. So head, this is like kind of standard on all of the challenges, or many of the challenges, that will have like a true thing and then we'll have a false thing. And a lot of times, like, it's extremely common that there's going to be recursion here because it's arbitrarily nested. So in this case, usually, like the base case is which is this one, the false case is where you stop. So the base case is like, in our situation here, is just the value. So we take like that thing, and this can be anything. That's why they don't have constraints. I think this would be like a string array or something like that. Yeah, whatever. But the base case is just this particular thing. So then we know that somewhere in here, we're going to do like tuple to nested object something. But first we have to, but that's like for the value. So first we have to put something here. And this is like, I think the skeleton of it. Is that right? Something like that. Yeah. So like, have you seen this syntax too much? I mean, this is not like a super common syntax.
I hadn't ever, usually when I see the syntax, my immediate response is, oh, I'm not supposed to be here. But due to my history of working with all things pattern matching in Elixir, I do follow the head tail pattern here is very common in pattern matching languages to like yoink things off.
Yeah.
And what I'm seeing here is the opportunity to basically make this recursive where head is now one of the keys and then you go through tail for the rest.
Yep. You got that part exactly right. The head is the key here. And then like we need to pass in tail somewhere in here. And then the only thing remaining is that we need the like the second, like the value, like because we may not have actually hit that end case with the value yet. There's an error. Let's see what it is. So head is not assignable to type string or number or symbol. Okay, so this is TypeScript complaining that like head could be, it's unconstrained. It could be anything. This is a funny thing because it's just like a happenstance of how the inferencing works, but you have to say, they added this thing where you can say like, extend string here, and that will kind of solve that case. There's a better way to do it, and I think we're probably gonna, I don't know what that error is on tail. It'll probably be a very similar thing. Tail does not satisfy the constraint string array because we gave it here. So I think we can take this away probably and it would work. Okay, all the tests pass, but the nicer thing to do would be to leave that there for our API consumers. Cool.
My immediate question now, just knowing how annoying TypeScript can be about accidentally casting over a type, since T extends string and T is extending this here, I am curious if I was to change this to number, would this type, this doesn't type error, even though this is an impossible case because T has to be, like the values within the T array have to be strings.
Yeah, what's funny about it is like actually I think the most proper thing to do, there's this type that a lot of people I didn't know about it before I started property key. It's not really used very much in the TypeScript. Maybe we can F12 to it. It's just an alias of string or number or symbol, and it refers to all of the things that you could put as property keys, which is funny because like the pedantic side of me wants to object to the number part because, in JavaScript, you can't have number keys. They're always strings or symbols. But yeah, I mean, the way
what's interesting to me more is that you can break out and lie, where like this extend can extend to something that this can't actually be.
Yeah, what's interesting is what will happen in that case. Like let's play with one here. Let's do B1, and then we'll have to change this to 1. I think it would have to be like this, maybe. Okay, so what's gonna happen here? A number. Okay, so then we need to say property key array, and let's see what happened here. A2.
This has to be property key array here too, I think.
Oh, okay. Oh, good, good. Yeah, perfect. Cool. So then it works.
This works. My issue is the other way around though, because I write the definition here, T extends string. And from this point forward, t like here should not be able to override the type that I'm giving it here.
Yep.
And that's the thing that's happening. That's scary to me, is that I have specified t extends string, but now I'm extending it further. I almost want to do I don't know if this is possible.
Yeah.
No.
It's a weird thing for sure. Yeah. And it's easy to hit. Oh, I love the use of multi-cursor. Okay.
It's necessary for the type of thing.
Yeah, I mean, the only one weird case that is legit that happens sometimes that's really, really tough is sometimes you get into this situation where it says that it's you have an error with tail here. And the reason is because TypeScript considers this thing. So this here means empty tuple. It doesn't mean it's different and distinct from like any array, which is kind of how it looks when you first see it.
Yeah.
So that is a situation where it's legit that you have to specify something because sometimes you're recursing and whatever. But all right, let me show you. I always go and look up a bunch of different examples of how other people solve this. Thankfully, the challenges have a ton of different solutions on them. So here's one. It's a little different, but it uses the intersection operator to kind of do the casting sort of at this level, which is another way to solve it. And otherwise, it's the same. You can constrain the t. So okay, that's a quick one. These are all quick ones, I think. Oops. You can constrain the t, like we did with property key. Oh, this is pretty similar to what we have. I think property key is a good thing to be aware of. Let me show one more.
My only hesitation with this one is it feels like you're casting types in 3 different ways.
Yeah.
Where we're writing it in the top here, we are then casting it on this infer, and then we are assigning heads type here. This is 3 assignments in 3 different places. Mm-hmm. And if I was a developer like I am, who isn't good at this stuff, and I wanted to make a change here, I wouldn't know which one to change and where. Whereas at the very least with our solution here, it's consistent. I would even drop the t out on the top if we could, just to infer it off of this.
Right. The cool thing is usually it's a really good idea. I mean, it depends on the situation because you might want your API consumers to know what you're expecting them to provide. But the cool thing about this syntax is that if it doesn't match this condition, it will just fall through. So if you put extends number in here, it will match for all of those things that are numbers. And if this first item in the way it works is this is just the first item and this is the array of the last. If this first item here isn't satisfactory to the condition, then it will just pop through to the next thing. So it comes in handy sometimes. Let me show you. I think these are a little bit like deep tracks solutions here, but they're funny. There's 2 more I found around. So here's one. This person's saying this is a check for empty tuple, meaning did we exhaust the list of paths that we're going through? If so, provide u. So it's kind of inverted. And then they achieve the same sort of thing by grabbing the first element. And I don't know, it goes a little deep. You can infer the remainder like this. And if you put this is a placeholder value, it's kind of like that, just saying anything can be there. And on that note, finally, before we close it out, there's this one, which is very similar. It just uses that same syntax up front to grab the remaining things. And this is another way of saying do we have anything left? So it's interesting to see how different people approach the problem of finding out whether or not there are any remaining things left to iterate through. And then it just grabs the T0, which is this one. So they could have inferred it there, but just thought that was an interesting difference.
Yeah, very interesting. This was interesting.
It's fun. When we started this project, I wasn't sure if the alternatives like this would be that interesting, but it turns out that most of the time, just seeing how people approach the same problem different ways sometimes can be the most interesting part.
Yeah, absolutely. My only issue with all of these solutions is that they're using single letters, which is obnoxious. Come on, guys. There's no reason to keep using T for fucking everything.
Okay, you're gonna hate the next ones then. All right.
Oh God.
Let's keep going. Okay, easy enough.
I'll be protest renaming.
That's fine. I welcome you to it.